the equation that we have now looks like a term with two derivatives in R plus this lambda term. We're dividing by an R squared. This gets applied to this U function. Looks like that. So we said we're going to consider this for large values and small values of R. So for large values of R, these two terms disappear. They become negligible if R is large enough. And so we can rewrite this as that, and therefore like this. And we know that the energy is negative, so this term is actually positive. So we have a positive quantity, right? And so we're familiar with this kind of equation. It's telling us about the bending of this function u. That's not the wave function, right? It was in our one-dimensional systems. Now it's some u function related to the wave function, but we know how to treat this. So we know the solution to this looks like, well, it's an exponential growth or decay. We will pick exponential decay. So we have something like e to the minus square root of minus 2me over h bar squared r. And so the u function looks like that. So we should say proportional to that. Okay, so that's for large R. Now let's look at for small values of R, and then we'll combine the two. So for small values of R, this term dominates over this one, right? If we make R very small, this is the one that becomes larger. And so we have a minus h bar squared over 2m, two derivatives in u, plus this term with the L quantum number over 2m r squared u, and that therefore is equal to 0. Right, so this is sort of R goes to infinity, this is R goes to 0, and this equation therefore looks like two derivatives of u and R is equal to L times L plus 1 over R squared times u. And so the solutions look like u is proportional to R to the L plus 1, right? If we take two derivatives of this, we'll see that we'll end up being, we'll have this term here in front of the u with an R squared. Or we could have u goes like 1 over R to the L, or R to the minus L. But if L is not equal to 0, then this looks like 1 over R to the L, and for R goes to 0, this goes to infinity. So we have this function. So we ignore this possibility, and we can say that u is proportional to R to the L plus 1. And so overall, we can say that the u function, or the u of R function, must be proportional to some constant, right? R to the L plus 1, e, or exponential of minus minus 2me over h bar squared r. This is the kind of solution to this function, and so we can get the wave function from this, and we'll look at then overall solutions.